Hello friends, welcome to another video tutorial by Elisa. This is the series on microcontroller peripherals and interfacing, and today you are going to learn stepper motor interfacing. So let us first have an overview of the video. First we will have introduction to stepper motor, then we will study the working of stepper motor, then we will try to interface stepper motor with 8051 microcontroller. In that, we will first code the 8051 microcontroller using Microvision 4. We will simulate the code in Proteus software, and then we will look at the hardware of the circuit. So, what is stepper motor? Stepper motor is a device which converts electrical pulses into mechanical movement. It is a kind of DC electric motor that divides its full rotation into number of equal steps. The position of the stepper motor can be commanded to move and hold any one of these steps without any feedback sensor. It is used in wide range of applications for position control, which includes disk drivers, dot matrix printers, robotics, etc. The commonly used stepper motor has 4 windings and a paired center tapped common terminal. It is also called as 4-phase or unipolar stepper motor. Its diagram is shown here. ABCD are 4 stator windings and the other terminal of ABCD are common, which is center tapped. Now let us have a look on the working of stepper motor. The rotor of stepper motor is generally a magnet which is surrounded by 4 stator windings, and as we energize the windings, it will make the rotor to rotate. As the current will flow through windings, it will cause electromagnetic force and hence the motor will rotate. This is the simple working principle behind stepper motor. The stepper motor can be operated in various conditions such as wave stepping, full stepping and half stepping. We will have a look on each of them one by one. First, let us have a look on wave stepping. In this, only single phase is activated at a time, therefore the motor won't have much torque. As you can see in the animation, only one phase is activated at a time, and this is simple working of wave stepping. This wave stepping is very rarely used because we are going to see full stepping, which is used as it is advantageous on wave stepping. In this, 2 phases are activated at a time so that the motor will have maximum rated torque, and as soon as one of the phase is turned off, another is turned on. So at a given time 2 phase must be on, and hence this provides greater torque. But full step and wave step does not provide better resolution, so we move towards half step. Half step is combination of wave step and full step. In this, one coil is activated at a time and then 2 coils are activated. So it is just addition of wave step and full step. This increase the angular resolution. As you can see, in wave step and full step, this rotor used to rotate only 4 times. Now it is rotating in 8 steps. In full and wave, it was rotating for 4 steps. So the resolution is almost doubled, and that is why half stepping is used to increase the resolution. So let us now try to interface the stepper motor with 8051 microcontroller. Here is the excitation table for the wave stepping. As we saw, only one phase was activated at a time. So first A, then B, then C, then D will be on, and this process will continue. So writing the table for the same, first A is made 1 and rest all are 0, then B is 1, rest all 0, then C is 1 and then D is 1, and this process will continue. So now let us write the code for the same. This is the code for interfacing stepper motor with 8051 microcontroller. First we have declared port P2.0 1, 2, 3 as control pins for stepper motor. Then in the main we have configured port 2 as output port, and here we are writing the code for wave stepping. First A is made on, then we have provided it with the delay of 500 milliseconds. Then B is made on, then C is made on, then D is made on. So now let us build this code. Now hex file is created. Now let us simulate the code. This is the connection. Port P2.0, 1, 2, 3 are used, and we have used this motor driver IC ULN2003 because the current provided by the microcontroller is not sufficient. So in order to drive stepper motor or any motor, you must use motor driver IC. Here we have used ULN2003A. Now first let us include the hex file we have created. Now the hex file is inserted in the microcontroller. Now let us run the code. As you can see, the motor is running in steps 35, 45 by 10 degrees. Now let us do the same for full step drive. First, as we saw, two phases are activated at a time. First A, B are made on, then B and C are made on, then C and D, then A and D, and this continues. So writing the table for the same, first A and B are made on, then B and C are made on, then C and D, and then A and D. So let us write the code for the same. For full step sequence, A and B are made on first, given the delay of 500 seconds, then B and C, then C and D, and then A and D. Now let us build the code. The code is built successfully. Now let us first insert the code. Now let us simulate it, and as we can see, the motor is running by the angle of 10 degrees, step of 10 degrees each time. Now let us do the same for half step and observe the change in resolution. As we saw, half step is combination of wave step and full step. So first only A will be on, as you can see here, then A and B will be on, then only B will be on, then B and C will be on, and so on. So writing the table for the same, first A will be on, then A and B will be on, then B, then BC, then C, then CD, then D, then DA. Now the funny thing is, you can compare this with wave stepping and full stepping, and you can observe that odd number of terms are of wave stepping and even number of terms are of full stepping. So if you split this code, you will get the sequence of both wave stepping and full stepping. Now let us write the code for the same. First A is made on, then AB, then B, then BC, then C, then CD, then D, then AD, and each of the step is given the delay of 500 milliseconds. Let us build the code. And now let us insert the code in Proteus. Now you can observe that the resolution is increased for wave and full step. We saw the difference of 10 degrees after each step. Now here we can observe the step angle has reduced to 5 degrees, and hence it provides better resolution. Therefore, if you want resolution, then you can use half stepping, and if you want maximum torque, then you can use full stepping.
Now let us discuss the hardware requirements of the project. First of all, you will need ULN2003 motor driver IC or any other motor driver IC, then you will need stepper motor, and then you can interface it with any microcontroller. So I have visited Amazon.in. Various stepper motors are available, but I have preferred this because it comes with ULN2003 board, so you can buy it, and it is by Kids Guru, and the price is only 248 rupees, so it's quite affordable. So you can have this as your hardware. So thank you friends for watching this video. Please like and subscribe, and don't fail to visit our Facebook page www.facebook.com/WCSElisa. Thank you.